Chemistry Chapter 19 Lattice Energy Video 1. Now when chemical reactions take place, there is a change in energy content in it. So we have categorized depending on whether it gives out energy or whether it takes in energy, as exothermic and endothermic chemical reactions. So when ions combine to produce an ionic solid, there is a release of energy. So releasing means it is exothermic, and at the same time the symbol for these type of chemical reactions should go to your head. So what happens is, symbol is exothermic means the products will have lesser energy, so that it is a negative sign is what is going to be there, right? So this energy that is released when a crystalline lattice is being produced from gaseous ions is known as lattice energy, and it is represented as using this delta H standard symbol. This is the standard symbol, standard symbol lattice for that, right? So then this particular lattice energy can be defined as this is each and every word in here is important, so you have to make sure that you know what you're talking about, and also each part you cannot miss. Lattice energy is the enthalpy change when 1 mole of an ionic compound is formed. Remember that 1 mole of ionic compound is formed. We are not talking about how many ions get together, but we are talking about 1 mole of ionic compound being produced from its gaseous ions under standard conditions, from its gaseous ions, right? Now sodium and chlorine get together to produce sodium chloride. Sodium ion has to be in gaseous form, and they produce a solid crystal, right? So now let's look at these examples, then you will be able to understand them. Sodium gas, Na plus gas, and chlorine minus ion, the again gas, produces sodium chloride solid. And because energy is given out, the lattice energy is going to be negative. A negative number is going to be there, right? So that is negative 787. So as you can see, we have got a negative sign because it is exothermic. Then let's look at the next example. Magnesium and chlorine joining together to produce magnesium chloride. Because magnesium has a charge of 2 plus, to cancel out the 2 plus charge, there has to be 2 chlorine atoms joining. But that doesn't make it goes actually parallel to our definition. 1 mole of an ionic compound is formed. So MgCl2, that is only 1 mole. Even though to produce that we require 2 moles of chlorine, that doesn't really make it doesn't really change anything. Why? Because we are looking at only 2 moles of chlorine ions, but we are looking at only 1 mole of magnesium chloride lattice, so the ionic compound. So the definition says 1 mole of an ionic compound is formed, right? 1 mole of an ionic compound is formed. So it is not about how many moles of atoms combine or the ions combine. It is about 1 mole of ionic compound being formed. So again, it actually follows the definition. Therefore, we are on safe grounds. So then delta H lattice is equal to negative 2526 kilojoules per mole. Why? Because energy has been released. I hope you understood that. So that is quite important. Then it is the gaseous ions that combine to form the ionic solid. That is one thing that you must remember in the definition. Then the lattice energy is always exothermic. So when you do calculations and if you get a positive number, that means you have made a mistake somewhere. So you have to correct it. You have made a mistake somewhere and you have to absolutely must correct that, because delta H lattice energy is always exothermic, right? The large exothermic value of the lattice energy shows that the ionic lattice is very stable. So what does that mean? Now what it means is, now when ions, two or more ions get together to produce 1 mole of ionic compound, if a lot of energy is being released, that means to reverse that reaction we have to produce, or we have to give it a very high amount of energy, because the same amount of energy has to be given to that. So giving that amount of energy is not easy. So as a result, if the lattice energy is high, or rather low in this particular situation, because it is negative value, if the negative value is low, if you compare the sodium and magnesium, sodium chloride and magnesium chloride scenario, you can see that magnesium chloride has a negative 2526 kilojoules per mole. So that means it is more stable. It is more stable with regards to its, in respect to its gaseous ions, and also it is it will be stable. Now in this particular situation, magnesium chloride is more stable than sodium chloride. It is easy to break, comparatively it is easier to break the sodium chloride bonds rather than the magnesium chloride bonds. However, we cannot actually determine the lattice energy of a compound by simple experimentation. So we use the Born-Haber cycle to find the lattice energy of a particular reaction. So this will actually have a lot of values and a lot of definitions coming our way. Let's do the first question and then go to the second part of it. Please do question number 1, and after that we will discuss it and we will go to the next part.